Okay, on this problem, they're giving us a function, big, long, complex function, fifth degree function. And they're telling us 2i is a 0. They want us to find all the zeros of p of x. And they say, hint, since 2i is a 0, negative 2i is also a 0. They basically come in pairs. The rule there is when there's when you have a complex number that is a 0, like, I don't know, 7 plus 3i, then the opposite sign on I on the imaginary part, is also a 0, which means 7 minus 3i. See what I'm saying there? They call that the complex conjugate. I'm not going to quiz you on that, but just letting you know. So anyway, you change the sign on the imaginary part. So that's what's going on with 2i and minus 2i. It's just changing the sign on the imaginary part. It's really, it's probably giving too much detail, but it's like 0 plus 2i. You think, where's the real part? It's 0. So it's 0 plus 2i and 0 minus 2i, right? So anyway, enough said. They're telling us negative 2i is a 0, 2i is a 0. They always come in pairs. Imaginary zeros come in pairs. How about I say it that way? So imaginary zeros come in pairs. Okay, so what? Well, we have to, what's the game plan here? We have this x to the 5th power that we have to break down. So what's the first step according to the notes? Let me go there. According to the notes, we are, let me see if I can grab the notes. There it is. Exam 3 notes. Basically, how do you find all the zeros of a function? Step 1, graph it at GeoGebra.org and observe 1, 0. So that's the first step. So we'll do that step. Step 1, graph y equals 3x to the 5th plus 20x to the 4th plus 55x cubed plus 110x squared plus 172x plus 120 at GeoGebra.org. Okay, I'm gonna do that right now. I'm gonna show you my screen as I do that. Let's go there. So here's GeoGebra.org. I'm gonna type in y equals that function, 3x to the 5th power, using the up arrow button, plus 20x to the 4th, plus 55x cubed, plus 110x squared, plus 172x, plus 120 equals, let me double check that I have that right, 3x to the 5th plus 20x to the 4th plus 55x cubed, that looks good. Plus 110x squared plus 172x plus 120. Yep. All right, you can see the graph on the screen there. So just grab one of those zeros, one of them that's a whole number. Doesn't really matter which one. How about the negative 3? Now you could do the negative 2. Either one. Doesn't matter at all. They're both going to end up being actual answers. So I'm going to go with the negative 3. So here we go. So x equals negative 3 is a 0. I'll say so is x equals negative 2. But anyway, we see that from the graph, right? Let me go back to the iPad that I just wrote that on. So you can see that what I just wrote. All right, so here's what I just wrote. X equals negative 3 is 0, so is x equals negative 2. We got that from the graph. Okay, that's step 1. Step 2, perform synthetic division for the first 0. So it's synthetic division time. Now, here's the trick on this one. This one's going to be a very long problem. So this is step 2. This is the first synthetic division. Basically, well, yeah, let's go ahead and do it. Well, yeah, let me give you the game plan right now. See how this is x to the 5th? Because it's x to the 5th, we're going to have to do synthetic division 3 times to bring it all the way down to x squared. Because every time we do synthetic division, we lower its power by 1. So we're going to have to do 3 synthetic divisions to get x squared, then use the quadratic formula, the negative b plus or minus, that whole thing. That's the game plan. So that's the plan. 3 synthetic divisions to get x squared, then use the quad. Because you have to get, you can't use the quadratic formula until you get it all the way down to x squared. So you're going to have to do it 3 synthetic divisions to get x to the 5th to come down to 4th, 3rd, 2nd, all the way down to x to the 2nd, and then you can use the quad. So the first, and you use a 0 to do it every time. First synthetic division, I'm going to use x equals -3 as the 0. After I'm done with that, I'm going to use the 2i and the -2i. Could you use the -2? You could. It's not quite as easy. I'm just going to use one of the real zeros and both of the imaginary zeros. All right, let's do it. So here we go. So first off, I'm going to put the -3 out there. All right, and I'm going to put the coefficients right here. 3, 20, 55, 110, 172, and 120. All right. So now let's do it. So you bring this down, and then you let this come around. Multiply, right? And write it right there, -9. -3 times 3 is -9, and then add these up. What do you get? 20 minus 9 is 11. So I keep going, and it goes right here. Multiplies -3 times 11. It's -33. Add these up, 22. Multiply -3 times 22, -66. So what's that going to be? 46? No, 44. Yeah, 44. And then keep going one more time here. Multiply -3 times 44 is minus, was that 120 and 12, 132? Oops, I'm adding these up. Add that up, it's 40. And lastly, you multiply -3 times 40, -120. Perfect. That's what we should get, 0 as your remainder. If you don't get 0 remainder, you mess something up. 0 remainder, beautiful. All right, so we got it. So now, we're going to do our second synthetic division. Okay, so here we go again. This is going to be the messiest synthetic division. Okay, and I'm going to bring down the answers we got from the last one, the 3. Oops. Try that again. Oops, come on. Okay, so 3, 11, 22, 44, oops, it was a sloppy 44, 40. Okay, and what am I going to use? This time I'm going to do it with my second synthetic division. I'm going to use one of the 2i that they gave me. So now, this is a little tricky. Bring down the 3. Okay, and now we multiply. So 2i times 3 is 6i. And then we add these. Now, how do you add those? Well, it's just 11 plus 6i. Those cannot combine. It's not 17. I, because if it was 11i and 6i, that'd be 17i, but it's not. It's just a plain 11 and a 6i, real part, imaginary part, unlike terms, they just stay separate. Okay, now the next one gets even more tricky. So I'm going to take 2i, and you've got to multiply both of those. So let me write it right here. You get 2i times 11 plus 2i times 6i. Just, it has to distribute to both of them. What is that going to be? 22i plus 2 times 6 is 12, I squared. See how I times I is I squared? Now, do you remember what I squared is? Plain I just stays I, but I squared is -1. Remember that? It's been a while since we've done that. So this becomes 22i minus 12. Did you track with that? Plain I just stays I, but I squared, that doesn't stay, it's replaced with -1. So we get 22i minus 12. Write that right here, 22i minus 12, and then add these up. So what happens? Well, 22 take away 12 is 10, so we get 22i plus 10, right? 22 minus 12 is 10. Okay, next one. Now, the 2i is going to multiply both of those. We put it right here. So it's 2i times 22i plus 2i times 10. So that's what? 44i squared plus 20i. And again, remember what I squared is? We never leave I squared. That's -1. And so that's -44 plus 20i. Let me write that in. -44 plus 20i. All right, and then add these up. These cancel, don't they? So it's just 20i. That was nice. All right, we're almost there. Now the 2i multiplies this, and the answer goes right here. 2i times 20i is 40i squared, which is what? Which is equal to -40. Because remember, I squared is -1 here. I can show it right here if it helps. 2i times 20i is 40i squared is 40 times -1 is -40. So the result there is -40. And of course, it's got to be -40 because we got to get a 0 remainder in the last spot. That tells us we're on the right track. Okay, that was our second synthetic division. We got to do it one more. Why so many times? Because it was x to the 5th. We got to get it all the way down to x squared so we can use the quadratic formula. That requires 3 synthetic divisions. Every time you do synthetic division, it drops by a power. So we did 2i. Now it's time for -2i. That's why it was important that we know that they come in pairs. Okay, so step 4, the third synthetic division. All right, this is the last one. And last time we did 2i. Last time we did 2i right here. So this time we're going to do -2i. All right, bring down the items. What are they? 3, 11 plus 6i, 22i plus 10. The answers from the last one. 22i plus 10 and 20i. There they are. Here we go. Synthetic division. Bring down the 3. We're going to do it again. This one will actually go smoothly. This will be -6i. Watch all the I parts will just be canceled out. You add these up, 6i and -6i gone, we got 11. Multiply right here. And so it goes right there. -2i times 11, -22i. Add them up, bye-bye I part. It's just 10. See how that's working out perfectly? Multiply here, -20i. That's added up. That's 0 remainder as usual. All right, so we did our third synthetic division. So what do we have left now? Now we have 3x squared plus 11x plus 10. We have an x squared equation equal to 0. So now we can use the quad. We're getting so close. It's a very long problem. So this is our A, our B, our C, step 5. Use the quadratic. So we had to do 3 synthetic divisions, right? We had to get all the way down to where we could use the quad. And so now the quad, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. This is going to be negative plus or minus b squared minus 4ac all over 2a. So b is 11. This should be 11 right here. B, negative b, plus or minus b squared minus 4 times a times c all over 2a. Okay, so what do we get? That's going to be, oops, negative 11 plus or minus, this will be 121 minus 120, that's convenient, over 6, that's negative 11 plus or minus the square root of 1 over 6. So that is negative 11 plus or minus 1. Square root of 1 is just 1, right? We get there? And so that's negative 11 plus 1 over 6, or negative 11 minus 1 over 6. So that is negative 10 over 6, or minus 12 over 6. We are almost there. Reduce these fractions, divide by 2, top and bottom, negative 5/3, or this is just negative 2. There we go. All right, so what are all 5 zeros? Well, from the beginning, remember we did the graphing and we found that, what did we find? X equals negative 3. We also found negative 2. See how that showed up in the end anyway? Yeah. So negative 3. So we found negative 3, comma, and then they gave us that 2i and minus 2i were zeros. So 2i minus 2i, and then right at the end, we found negative 5/3 and negative 2, which we actually knew from the beginning by looking at the graph. But there they all are, all 5 zeros. So that is a lot of work. There we go.